similar to this.
Now, if this is in that, and if this compound
Any element of symmetry, no center of symmetry, no line of symmetry. So this one be optically active. And this, we take this one back again to 360 degrees. You can see this carbonate group, methyl group to this angle. So this one, you can see back to it. This is horizontal. So they are in the same place. This one is this. There's no there, and this one is like the angle 0 degree. So they will be in the same form.
It can be.
So this one will be
plus one form.
And another, if you now look at this can be the mirror image of this one, but they are not super
Alkyl group is here.
possible.
Carbonyl group
But
is here.
they are also
methyl group here.
mirror.
You can see in
Mirror
this.
image.
If
Not-
there's a cross
They
of
are not
line,
mirror image, but
you can see methyl.
this one is plus
Carbonyl,
one,
carbonyl
and this one is
group
minus
attached,
one.
here.
So in my subsequent
This one,
videos, I will
There is
elaborate
no
more.
line of symmetry because the substituent here is
Whether
different from
it
this,
is resolvable
and the substituent here
or
is different
resmizable,
from this.
or
This one,
easily resmized,
there is no
or it cannot be
line of
resolved.
symmetry.
In result, be whether it
But
cannot be isolated like this one.
There
It
is
can be
a
isolated, but it's not optically active.
center of
You can see
symmetry.
this.
Here,
It can be isolated, but
here,
not optically
and the center
active.
here.
What
There
will
is a
make it
center
to
of
be
symmetry.
isolated
Because of this,
and
there is
remizable?
element
It
of
depends
symmetry.
on
So this one will be
atom
optically
of the group
inactive.
attached to the auto position.
And now this one
And
will
one of the
take
rules
is
is
this
that
one again. If you add the radius of this and add the radius of this one, it should be
75
greater than 270 degrees. 95 Armstrong. In that, it is resolvable or it is remizable. Or it's not easily remized, but resolvable. In my subsequent videos, I will elaborate more on that. You can subscribe to my channel for your knowledge. Thank you.
So this will be optically active. And this.
Welcome to Ecovic Academy. Today we are going to discuss some compounds that possesses optical activity, but they have no stereogenic centers. And some of those compounds are biphenyls, spirines, and
They are
chromelins.
in the same place.
Today we are going to talk on
This
number
one
which is
is-
biphenyl. This is a biphenyl,
And this one is
two
like
benzene ring joined by a sigma
zero
bond.
degree. So
So under normal conditions, if
So this
we
one will
can
be
restrict one of the ring
plus
and
one
take
form
this one.
of this.
As you rotate it, it give you different isomers, and those isomers cannot
one,
be
but
isolated
they are not
except
super
you introduce a substrate to the
they are
four
also
auto
play-
positions. Auto positions.
They are
That's when you have
mirror
hindered the
image.
rotation.
None.
And if
They
the
have mirror image
rings
that have been substituted are forced to rotate. This one is plus one and this one is minus one. So in my subsequent videos I will elaborate more, and there are conditions that will warrant
whether it is resolvable
whether it
or
will be
resmizable,
active, not
or
because of
easily resmized,
using it-
or it cannot be resolved. The result be whether it cannot be isolated like this one, but it can be isolated, but it's not optically
One of those
active.
conditions
You
is
can
that
see this.
this
It can be isolated, but not optically active. What will make it to be isolated
like
and remizable?
It depends on if this is the chlorines of the atoms or atoms of the group attached
One of
to
the auto position.
auto position.
If here is chlorine 2,
And one of the
this one
reasons
will have. If you add the
a
radius
line
of
of
this
symmetry.
and add the radius of
And if
this one,
this
it should be
chlorine
greater than 2.95 Armstrong. In that, it is resolvable
it has disobeyed the
or it is remizable.
there is element of symmetry.
It's not easily reminded.
For each of the optical axis, there should not be any element of symmetry.
I will elaborate more on that. You can subscribe to my channel for your knowledge.
Practical example of this device.
This one is restricted. If this one is fixed and here being rotated, it gives you isomers that cannot be separated. In order to reduce the rotation, the speed of rotation is for you to put a stop effect down to the 4
auto positions. And here is a practical example. You can see carbonyl group or carboxylic functional group here attached to this. It's attached to this. Alkyl group here, or methyl group. This is a methyl group. This is a methyl group. This is a methyl group attached to it. Now, as you can see, this is the two of the rings. This is the sigma bond. It's a single bond. There's a carbon here, carbon. All these places are carbon, 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 carbon. Now, if this is assumed in that, and if this compound is forced to rotate at 90 degrees through 90 degrees, it will be like this, fixing one on the side. You can see this angle is perpendicular to this angle. You can see here is here, and this is perpendicular. This is the vertical, and this is horizontal. You can see this is the perpendicular side, which is this one. You can see. So in this, there is no any element of symmetry. So this will be optically active, and it can be isolated from the mean solution. And another of it, if you now rotate it through 180 degrees, you can see the alkyl group is here, the carbonyl group is here, carbonyl group here, methyl group here. You can see in this, if there's a cross of line here, you can see methyl, carbonyl group attached here. This one, there is no line of symmetry because the substituent here is different from this, and the substituent here is different from this. This one, there is no line of symmetry, but there is a center of symmetry here. At the center here, there is a center of symmetry. Because of this, there is an element of symmetry. So this one will be optically inactive. And now this one rotates this one again. This is 75 degrees. Sorry, 270 degrees. This is a methyl group here. Methyl group here. It's a carbonyl group here, or carboxylic functional group. Methyl group here. You can see this one has this one is perpendicular to this. So this one, there's any element of symmetry, no center of symmetry, no line of symmetry. So this one will be optically active. And this, we take this one back again to 360 degrees. You can see carbonyl group, methyl group. So this one, you can see back to it. So they are in the same place. This one is there, and this one is like the angle 0 degree. So they will be in the same form. So this one will be +1 form of this. In other words, this can be the mirror image of this one, but they are not super impossible. But they are also plane mirror. They are mirror image. They have mirror image, but this one is plus form and this one is minus form. So in my subsequent videos, I will elaborate more whether it is resolvable or resmizable, or easily resmized, or it cannot be resolved. In resolved means whether it cannot be isolated like this one. It can be isolated, but it's not optically active. You can see this. It can be isolated, but not optically active. What will make it to be isolated and remizable? It depends on the radius of the atoms or radius of the group attached to the auto position. And one of the rules is that if you add the radius of this and add the radius of this one, it should be greater than 2.95 Armstrong. In that, it is resolvable or it is remizable, or it's not easily remized but resolvable. In my subsequent videos, I will elaborate more on that. You can subscribe to my channel, watch for your knowledge. Thank you. Some compounds that possesses optical activity, but they have no stereogenic centers. And some of those compounds are biphenyls, spirines, and cumulines. Today we are going to talk on number one, which is biphenyl. This is a biphenyl, 2-benzene ring joined by a sigma bond. So under normal conditions, if you can restrict one of the ring and rotate this one, as you rotate it will give you different isomers, and those isomers cannot be isolated except you introduce a substituent to the 4 auto positions. Auto positions. That's when you have hindered the rotation. And if the rings that have been substituted are forced to rotate, they will give you different isomers, and which can be separated or isolated. And there are conditions that will warrant whether it will be optically active, not because of you are giving it a substituent or introducing a substituent to the 4 auto positions, but there are conditions. And one of those conditions is that this compound that you have been substituted, there should not be any element of symmetry. Element of symmetry means, like a case study here. If this is a chlorine group attached to one of the auto position, if here is chlorine 2, this one will have a line of symmetry. And if this is chlorine and here is chlorine, this thing will possess a center of symmetry. And by that, it has disobeyed the condition that there is element of symmetry. And the condition for it to be optically active, that there should not be any element of symmetry. I will give you a practical example of this is the biphenyl. This one is restricted. If this one is, today we are going to discuss fixed and here being rotated, it give you isomers that cannot be separated. In order to reduce the rotation, the speed of rotation is for you to, some of those compounds are biphenyls, spirines, and cumulines. Today we are going to talk about example number one, which is biphenyl. It's a biphenyl group or benzene joined by the sigma bond attached to this. So under normal conditions, if you can restrict one of the ring and rotate this one, as you rotate it, it will give you different isomers, and those isomers cannot be isolated except now you introduce a substituent to the 4 auto This is the
positions.
sigma bond.
Auto position.
There's a carbon here, carbon, all
that
these things are carbon,
if the
carbon,
rings
carbon. Now, if this is a big index, and if this compound is forced to rotate at 90 degree, and there are conditions that will warrant like this, whether it will be optically active, not because of you are giving it a substance or introducing a substance to before.